Hey everyone, welcome back to a new video where I'll be showcasing some updates to my 3D engine for 3DO Mechanicus, inspired by the game Killing Time. For anyone new, this engine was created from the ground up. I am using a Doom style editor to create world geometry and object placement and some other things, but I have my own data converter that takes that WAD data, chews it up into my own custom data format, and then my engine reads from that, and then I rebuild everything. So one of the first things to show here is I rewrote the player controls to be a little more physics-like. So there's acceleration, friction. You can also tilt the camera as you strafe. It still needs a little work, but it's getting there. You can see that Skybox back there, and I have logic to determine when to show and hide the Skybox, and I do that for 3 reasons. Now, in order to control that, I'm using something called specials, which is new in the engine, and I'll be covering that in a bit. But the reason why I need logic to show and hide a Skybox is because I have a render distance, a max render distance, and so if you're running around an interior structure and say a wall far off in the distance is not being drawn, you wouldn't notice it now because it would be dark and I have lighting. But if I'm drawing a skybox as the background, you would see the skybox bleed through the geometry that's missing. So I need it for that reason, and also because I don't want to draw it if I don't have to. But I'll cover the specials in a bit on how that works. So let's come over here, and all right, so now we have this enemy here. Now you'll see that this enemy has different angles. I can be looking at different angles, and 8 angles to be specific. And the way this works is depending on where the player is standing relative to the facing direction of the enemy, I'll know which quadrant here, or which quantized area here, to pull information from. And so what's nice about this add-on to my engine as well is that I'm supporting the concept of symmetrical game objects that may not need animations for every angle grouping. So for example, if I was trying to draw the mirrored version of this set, I can just flip the graphic. It's symmetrical. I don't have to do anything else but flip it. So what the engine will do is when it figures out which set to grab, it will try and, if it doesn't exist, it will try to grab its opposite. So an example would be like the hunter with the rifle. He's holding it right to his right. He's not symmetrical. He would be using all 8 sets of animation versus this guy. By the way, I've been creating a lot of documentation lately as I go, because it's quite a complex project and I take breaks often. So I need to be able to refamiliarize myself on how this stuff works. But at some point I'll be sharing more of the documentation on the engine's inner workings. Okay, also these enemies now, they can be shot, feel pain, and be destroyed. So you'll see there's some blood splatter. There's some blood splatter there. You see there that he let out a little scream. So that's the pain that he's feeling. So like Doom, I programmed a chance for enemies to feel pain. And if they feel pain, it'll behave as an interrupt. It'll stop whatever they're doing. And they'll go through that pain state cycle and then go back to what they were doing. And now he's destroyed. And you can see the particles hitting the wall in the back. Some items to pick up. So I had to completely rewrite all my game object code. It's much better now. The controls feel much better now. So, okay. So now I have doors. My engine supports 3 types of doors. Doors that open vertically, horizontally, and doors that rotate. I'll get into how they work in a moment. I kind of want to showcase some more stuff first. Here we have a rotating door. That's very Killing Time-esque. And you see how it has different textures to switch. And so the doors have state, and when it's opening, I can swap out what texture to show. I also have teleports, which also uses specials, which I'll get to. So the teleport system works just like it does in Doom and just like it does in Killing Time. So I am now in a different part of the map. By the way, I didn't show this on the other guy, but these guys are melee ranged and they can attack you if you get too close. They just don't deal any damage yet. There you go. All right. So this is an example of a horizontal opening door. By the way, the doors have colliders, and they're pretty accurate. Let that close, and then you see it's intercepting the bullet and the player. Come back in here. Here's an example of a vertical opening door. And for the sake of completeness, we'll just kill everything. Alright, now the hitbox on the enemies are wide. I did that to make it easier to hit, but the bullet's collision is actually pretty accurate. So if I get into this corner, strafe a little bit, you can see how it misses. Okay. Okay, so let's talk about specials, because doors are using it, the teleport's using it, and enabling, disabling the Skybox is using it. So in the editor, let's go to the Skybox one first, because that's the easiest to explain. But you'll see that I have this green line segment here. So it's green because it has a special on it. And if I look at it, that special value is 2000. So that's just a value that I'm using for my engine. It has specific meaning. And you'll notice that these line segments, they have a normal. Here it's pointing up. So when you cross this trigger in my engine, I'm able to figure out which side you crossed from. So if you crossed opposite that normal, then you have entered the trigger. And if you have crossed in the same direction as that normal, you left the trigger. And it doesn't matter if you run in backwards or what, because it's using vectors. At the end of the day, it'll know which side you came from. And in my code, I have an array of function pointers which are callbacks to the different triggers that occur when you run through these things. And so if we look at Skybox, do Skybox, depending on the direction you came from, I'm either enabling it or disabling it. So that's the easiest one to explain. Okay. So now let's look at another one. So let's look at the teleport. So in order to get teleports to work, first I need a trigger. And I have one here, which has its own value of 97. And this trigger is going to map to this callback. So now what's left to figure out is, where do you go? And when you arrive at your destination, which angle should you be facing? You can see how if I highlight this line segment, it's already pointing up to that sector that you teleport to. The reason why it knows that is because this sector has a tag on it, a unique tag, and this line it has that same tag on it. So you can see it's tagged with the value 3, and this sector has a tag of 3. So that's the link. Finally, to answer the where to put you, where to face you, your destination needs to have a special game object, the teleport game object. That teleport game object, it has the angle that you'll be facing, and it has position. So in this case, I'm going to be placing the player right in the middle and facing to the right. Okay. And also I use this game object for the special effects of the teleport itself. So when you teleport and you see that green special effect, that's actually the game object being enabled and being rendered. And then each game object has its own callbacks, so it knows when to turn itself off, and then it's no longer rendered anymore. I'm not sure if Doom did that, but that's how I leveraged game objects for the special effects as well. Okay, and then the last special to talk about is doors. So for doors, I had to do something a bit different than what Doom did. So if I'm not mistaken, the way doors work in Doom is there are sectors that have a ceiling that goes up and down, if I'm not mistaken. And I needed doors that rotate, doors that go up and down, doors that go side to side. Another challenge, aside from more door types, is that my engine, it knows at a surface level what a sector is. But the inner details of a sector have been abstracted away by my WAD data converter because I don't want to have to process every sector, every frame from scratch. It's one of the reasons why I think I have such good performance so far in this project. So the WAD converter will know all the geometry to build, where to put it, what attributes go where, the textures, all that stuff. And then my engine gets all that 3D geometry and builds the scene from it, but it doesn't understand. And it has like the values for the height and the floor and all that stuff, but it doesn't quite understand what a sector is like my tooling does. And so in order to make doors work, they have to be 3D geometry like everything else, and they need to be grouped in some kind of way where my engine can know what needs to be moved around, what needs to be rotated, what needs to be lifted to simulate doors. And I also needed some form of consistency. So if you're building doors, if you're trying to build it from scratch within the editor itself, well, that could be a little confusing because how do you know they're always going to be the same? And also that's going to take a lot more time. So here's my solution. Doors are sectors, and there's nothing in them. It's just a sector. And these sectors have their own special values. So 1000 would be a door that opens vertically. 1001 would be a door that opens horizontally. 1002 would be a door that opens in a rotated manner. So when my WAD converter encounters a sector with these special values, it knows it's a door, so it actually builds the 3D geometry for that door. And depending on the door, it knows how many faces to build. So if it's just a vertical door, you're going to get front, back, and bottom. If it's horizontal, you're going to get front, back, and side. And if it's rotating, you're going to get all four sides. So how does it know exactly where to put the door? Well, it's smart enough to know. So if we look at this sector here that's highlighted, it knows it needs to build the door inside. And so it's going to build it in its center. It also knows that that sector is more narrow than it is tall. Therefore, it's going to build it in a vertical layout. If it was in the opposite, right, where the horizontal axis was greater than the vertical, it knows it needs to build it in a horizontal layout. So my tooling is smart enough to figure that out. My tooling also has a thickness value, which later can be customizable, but that's how it knows how deep to make the door, the thickness to make the door. So quick high-level recap. Sector is tagged as a door type. My tooling will understand that, build the 3D geometry, and add that geometry to the sector, just as if it was a wall that was created through the editor. Okay, so now comes, how do you know that you're interacting with the door? And I do that using specials. So you'll see that I have a special here and a special here that point to that sector. Okay, so it's tagged accordingly like the others, like the teleport. These triggers, they have their own special value of 3000. That means you're around a door. If you come in from this side, the engine will cache it. You're in the zone. It knows there's a door here, and it knows which door. So my engine is able to quickly grab a reference to the door, and then from there, quickly grab the interior walls that make up the door to manipulate it. Now, what I could do is I could cast array and go, oh, there's a door here, and do it that way. And I may end up doing that later, but I was trying to figure out a way to reuse specials for these things. And so the interior geometry of this sector for the door, my converter will automatically tag it, so my engine knows exactly what makes up the door. And then from that point, each door type has its own logic for opening and closing, so I could do whatever I want, rotate it, move it. I know this sounds a little confusing. It's confusing for me to even explain it, and I wrote it. It's just it's kind of a confusing topic because I'm at a point where I'm having to do very specific custom things for the engine, but I'm using this editor that wasn't designed for the things that I'm doing, and I'm trying to give enough information to my tools to know how to bridge the gap between, that editor UI and ultimately what the engine needs. But it is working. I don't have the flexibility of, in Doom, to make a ceiling come down, for example, you just change the ceiling height. And that works because the sectors are built per frame, I believe. And that's just not something that's not something I can do in this engine. I think it would run probably at half the frame rate if I did that. But yeah, so that's doors. And the horizontal and the vertical doors are very similar in how they're set up. The rotating door is a little bit different because the rotating door, it rotates. And so if I build a rotating door within a sector this thin, there's going to be an issue because my engine relies on everything inside a sector to be rendered together. Whether it sorts itself or not, that needs to be processed as a whole for my depth sorting to work properly. And so if I have a sector that has geometry that leaves it, that geometry is going to get clipped and cut, and it's not going to look right. So that's why this sector here is so big, because it houses a rotating door. So if I look at its special, it's got a value of 1002, and my tool is going to understand to put the door here in the middle and build the geometry here, and then my engine is going to know to rotate it because of its special value. And it still has special triggers that sandwich the door to let the engine know, hey, there's a door here, and this is the door that you need to update when you interact with it. But because the sector is so big, because of the rotation gap, I was able to just put the triggers directly on the sector, unlike here where I have the triggers away, because you would collide with the door before you hit the trigger. But since this is so big, I can just put the triggers right on the sector's outskirts. So that's doors. So what else? I also added the ability for the camera to shake. So this is pretty interesting. It could be used for a lot of different things. What's really cool about this, one thing that's really cool about it anyway, is that I'm not modifying any level data. Let me turn this off before we vomit. I'm not modifying any actual level data for that. I'm only updating the camera's position because this is a 3D program, so I can move that camera wherever I want. The camera is abstracted in a bit where it relies on having a point of view, and a point of view is just a position and an angle. And so right now the camera is attached to the player. So wherever the player goes, wherever the player turns, the camera has a pointer to that, and that's how the world is rendered from that perspective. Well, what I did was I added offsets to position and rotation for when the camera is used to build the world view matrix that everything is rotated and translated from. It can optionally add offsets to not just angles but to position to create any kind of effects without actually doing anything to the level. So that's how that works. Really quick, if we look for update view matrix, darn it. So here we go. Yeah. So at a high level, I'm concatenating different matrices together in order to create the ultimate transformation for the view. And so here, this matrix represents position. And so it's taking the inverse of the camera position, because technically everything moves around the player. And then here's the Y rotation, which simulates the yaw, or looking left and right. I have an optional roll, which I added recently for the strafing. And only if there's an angle in the roll, in the Z-axis, do I concatenate this. Because again, I don't want to do anything that I don't have to do. You know, I would save a concatenation if I can. And so ultimately, this creates what I'm calling the view matrix. It's going to ultimately create this view matrix that the world then uses to transform itself around the player or around wherever the camera is. And here you can see that, like when the position is being set, I add any offsets that might be specified. And when that roll angle is being grabbed, I also add any offsets that it might have. And in my specials code, or not specials, sorry, I have an effects file now where I can create different effects from. And when the camera is shaking, I'm just modifying those offsets. So yeah, so that's how that works. So next up, there's a lot of cleanup that I need to do. I need to work on the enemy AI, at least a simple one for now, just to get things moving. And yeah, plenty of other things. I have quite a big list to go through. Also, I'm not sure if I mentioned this before, but I know I talked about block maps in a prior video. But these bullets here are using the block map to figure out what gets hit. So that's a very quick way to do a lookup. So the block map, if you imagine a big grid over this world, and every wall, every object, even the player, is inside of some block in the map at any given time. You know, these lines, these walls intersect the block map as well. And so when I fire the bullet, I search through the block map as the bullet travels to figure out what's around it and did anything get hit. And I might do that for doors. So maybe here I'll cast a ray through the block map, just a short ray, looking for doors. But for now, they're using specials. But yeah, hope you enjoyed. Appreciate you watching and your interest in this. If you have any questions, please let me know. I love talking about this sort of stuff. And stay tuned for more updates. Thank you for watching.